All right, guys, we're going to go ahead and finish up the notes from yesterday. It says here to complete, or we're going to complete the table to determine the zeros of the quadratic function. Remember, zeros are the same thing as the x-intercepts. So we're going to go ahead and do A. I know we did it yesterday, but let's go ahead and just recap here. What we did was we go to y equals and put that in, x squared minus 2x minus 3. And then what we're going to do is complete the table. Now, like I said, we did do this yesterday, and we found out that the table of values ends up being, I don't know, what do we get right next to the negative 2? 5. Next to negative 1, we ended up with 0. Next to 0, we had negative 3, negative 4, negative 3, 0, and 5. So these were the values we came up with yesterday after putting x squared minus 2x minus 3 into y equals. Now what we're asked to find is the zeros, or the x-intercepts. Now we don't necessarily need to look at the graph to find those zeros. You can also find them in your table. And those zeros are right here. All we got to do to find the zeros is look for 0 underneath the y column. Therefore our zeros, or the x-intercepts, are negative 1 and positive 3. So those are the two x-intercepts for the zeros. We're going to do the same thing with B. We're going to go to y equals again. And we're going to type in 2x squared minus 9x plus 7. So go ahead and do that for me. You'll notice this time in the table they did not give us any x values. And we're going to put our own x values. We just need to make sure that we do find the zeros, or the x-intercepts. So make sure in your table you have at least those two. One of them should be pretty easy to find. The other one's going to be a little bit trickier to find. So, all right, we're looking in the table. Anybody find one of the zeros? 1, 0. All right, so out to the side, 1 is one of our x-intercepts, or zeros. We're looking for the other one. Can you find it in the table? Probably not. Where else can we find it besides looking in the table? The graph. Go to the graph. And what are we looking for in that graph? The x-intercept. So notice that the second one that we're looking for falls between 2 and 3. Now it's possible that it's 3.5, but it's also possible that it's 3.4. So we need to double check and make sure we get the exact x-intercept, or the exact zero. So double check that for me. Is it 3.4? Is it 3.5? Is it 3.6? What is it? 3.5. Let's put that in our table, 3.50, which again, 3.5 would end up being one of our zeros, our x-intercepts. Now remember, we can either use that second trace feature in our calculator and ask it to calculate the zero for us, or you can also adjust your window to make it count by tenths, or 5/10 or so on and so on. Okay, so you can also do that. All right, let's go on to the next one here. C, they're asking us to use our calculator to sketch a graph of the function and tell where the x-intercepts occur. So it's basically the same thing, but this time instead of looking at our table, this time we're going to be looking at our graphs. So go to your calculator and let's graph y equals x squared minus 4x minus 5. Put that in. Whatever graph you see on your calculator, that's what you're going to schedule. Make sure you sketch that graph. All right, if we enter that correctly, we should end up with this graph right here. You were asked to find the x-intercepts, which in this case there are 2 of them. These are the 2 x-intercepts. We need to list those 2 x-intercepts down here at the bottom. What am I going to write down? What are the 2 x-intercepts? Negative 1 and 5. Positive 5. Again, all we're doing is looking for the x-intercepts. Okay, do the same thing for D. Go to your calculator. Let's go to y equals. And we're going to enter 2x squared plus 24x plus 72. Once again, we're going to graph it. Make sure you sketch me a graph. I want to see what it looks like there on the paper. So if we do this correctly, this is the graph we're getting. Notice it's a little different from C. And why is it different from C? There's only one x-intercept. There's only one 0. We are going to identify that 1, 0. And that x-intercept or 0 is negative what? Negative 6. By the way, we had a name for that. Anybody remember what we call it when we have one x-intercept? We wrote it down yesterday on our paper. Double. So there you go. Double roots. This is called a double root. So go ahead and write that down for me. Remember, yesterday we said that when we're working with a quadratic, we would always have two complex roots, and we do have two roots here, even though there's only one x-intercept, and it's negative 6. We call that a double root. It's the same answer twice. All right, last one, E. We're going to graph x squared minus 3x plus 5. So graph it. Whatever graph you get on your calculator, we're going to sketch that over here. The graph turns out to look like this right here. And since we're looking for the x-intercepts, what do you notice about this one here? There are none. There are no x-intercepts. All you're going to do here is write none. There are no x-intercepts. Which means we have, and I want you to write this down as well, no real solution. There's a solution. It's just not a real solution. And we're going to get real close to finding those imaginary solutions here pretty soon. So these are the three possibilities. We can have two x-intercepts, one x-intercepts, or no x-intercepts. If there's one x-intercept, we call it a double root. If there is no x-intercepts, well, then we have no real solution. All right, let's change it up just a little here. F, what they want us to do is a couple of things here. They want us to write down the zeros of the quadratic that's graphed. Then we're going to work backwards and find the zeros. And then we're going to actually use those factors to come up with the equation for that graph. So I'm going to give you the graph. You're going to give me the quadratic equation that goes with that graph. So we're working backwards. So here's how we're going to do it. We're going to start by finding the zeros, or the x-intercepts. There are two of them. There's one here and another here. What are those two x-intercepts? What is that? 2 and negative 3. So the first thing we're going to do is write down 2 and negative 3. Those are the zeros, the x-intercepts. Now, since those are the x-intercepts, we should also be able to find the factors. Remember yesterday we said we noticed there was a relationship between the factors and the zeros. What did we notice yesterday about the factors and the zeros? They were opposites. So what I'm going to do is I'm going to come over here and write down the factors. Now, I'm not going to write down x plus 2. Remember, it's going to be x minus 2. This is what we noticed yesterday. They were opposites of each other. Same thing over here with that negative 3. It's not going to be x minus 3. It's going to be x plus 3. The factors and the zeros are opposites of each other. Since I have the factors, now I can actually use some FOIL method here and expand this to come up with the equation in our standard form. So let's go ahead and go through some FOIL. The x times the other x is going to give us an x squared. The x times the 3 would give us a 3x. A negative 2 times x is a negative 2x. And a negative 2 times 3 is a negative 6. But I'm not going to stop there. I'm going to simplify that. The 3x minus the 2x. What do you get when you do 3x minus 2x? An x, positive x. So what I have here is x squared plus x minus 6. Throw a y in front of that. And we've got our equation. Now do something for me real quick. We're going to just double check, make sure we got the correct equation. So go to your calculator and let's graph x squared plus x minus 6. Graph it for me real quick. What we're checking for is to make sure that we get the same graph that we have here. And we can tell for sure we got the same graph by looking at the x-intercepts. If we did this correctly, on your calculator you should see your U-shape, just like we have here, with x-intercepts of 2 and negative 3. So if you're not sure about your equation, you can always go back and check it and comparing it with what you see on your calculator. Is that right? Did we get it right? Okay. So if you're not sure, double check. So again, remember, there is a relationship between our factors and our zeros. They're always going to be opposites of each other. Okay, next thing. Next thing we're going to do is we're going to find the solutions to our quadratic, but this time we're going to use something called the factoring method. A couple of steps here involved. First thing we're going to do is we're going to set each equation equal to 0. That's going to be our first step. After we have it equal to 0, then we're going to factor. Once we have it factored, we're going to take each one of those factors and set them equal to 0 and solve. All right, so those are the steps. Notice the fourth step is just a matter of checking to make sure we have the right answers. So here we go. First step. First step, get it equal to 0. So what I'm going to do is take this 6 right here and move it over here with its buddies. So now I'm going to end up with x squared minus x minus 6 equals 0. Move the 6 to the other side by subtracting. So there's the first step. Second step, factor. We're going to take that x squared minus x minus 6, and we're going to factor it. This is what we've been working on all week long, guys. This is why I've been asking you to make sure you know what you're doing when it comes to factor. X squared minus x minus 6, just like I did at the beginning of class. An x times another x is an x squared. What two numbers am I going to use though? 2 and 3? Nope. Remember, when I multiply them, they got to give me negative 6, but they also need to add up to a negative 1. Say that again. Negative 3 plus 2. Let's try this out. Negative 3 times 2 is definitely a negative 6. Is negative 3 plus 2 going to add up to a negative 1? Yes. Okay, so these are the factors. Let's not forget, it's still equal to 0. So that's what we've been working on. That's the second step. Third step, it says we're going to set each factor equal to 0 and solve. So in other words, I'm going to take the x minus 3, set it equal to 0. Then I'm going to take the x plus 2, set it equal to 0. So what I have here is two small equations. I need to solve those two equations. So for this first one, if I add 3, I end up with x equals 3. This is going to be one of my zeros, or one of my X intercepts, my solutions here. Come over here. Let's subtract 2. So 0 minus 2 is a negative 2. So we end up with 3 and negative 2. These are my solutions. Is there a way I can check this and make sure I've got the right answers here? What's that? Plug them in. We can plug them in. Is there another way? Graph it, and what would we be looking for in the graph? X-intercepts of 3 and negative 2. Let's just be on the safe side. Let's go ahead and check it real quick, guys. Let's put in x squared minus x minus 6. Put that in your calculator for me. And what you're going to check for is to see if it in fact has x-intercepts of 3 and negative 2. Is that right? All right, so 3 and negative 2. So we know we have the right answers simply by looking at the graph. Oh, by the way, this equation right here that we were working with, did it have a y in it? Was there a y in that equation right there? No. So what do we call these if there is no y in the equation? We talked about this in the notes. We call them solutions, or, no, not zeros, roots. Remember, it's on the first page, guys. These numbers right here, we call them solutions to the equation, or we call them roots. And we only do that if there is no y. That, again, is on our first page down there at the very bottom. Call these solutions or roots. All right, let's keep going here. Got another one very similar. Again, first step, get the equation equal to 0. So that's what I'm going to do first here. I'm going to take the negative 9x and move it to the left, so that becomes positive 9x. I'm going to take the 5, do the same thing, move it to the left, so now that becomes negative 5. So there's my first step. Get it equal to 0. Second step. Now we're going to factor. Now to factor this is going to be a little different here. The ones that we've been working on have always had a leading coefficient of 1. This time we have a leading coefficient of 2. So anybody remember how to do it when there's a 2 in front? We had a method called bottoms up. That's what we're going to do here. By the way, notice there is no GCF, so we don't have to worry about greatest common factor. So here's how bottoms up work. First thing we did was we rewrote the polynomial, or the trinomial that we're working with here, as x squared plus 9x minus 10. And where exactly did that negative 10 come from? The leading coefficient 2 and the constant negative 5. When I multiply those two numbers together, I get a negative 10. Now the reason we did that is because now it's a lot easier to factor that right there. That's what we've been working on here. So x times x is x squared. Again, what are the numbers I'm going to use? What are factors of negative 10 that are also going to add up to a 9? What two numbers can I multiply together to get negative 10 but also add up to a 9? What's that? 10 and negative 1. Notice how 10 times negative 1 is negative 10. And when you add those two up, you get a positive 9. But we don't get to stop there. We're using bottoms up. So underneath the 10 and underneath the 1, we're going to put a 2. That's that leading coefficient that we were working. Notice how 10 over 2 can be reduced. 10 divided by 2 is a 5. 10 divided by 2 is 5. Now in this other fraction, 1 over 2 cannot be reduced. It's already simplified or reduced. So we're not going to leave it like that though. What we're going to do is bring that bottom number, that 2, up in front of the x. This is why we call it bottoms up. So 2x minus 1 is how we're going to write that. Bottoms up. Bottom number comes up in front of the x. So now I have my factors. Again, don't forget it's still equal to a 0. So that was the second step. Third step, set each factor equal to 0 and solve. So I'm going to take the x plus 5, set it equal to 0, and I'm also going to take the 2x minus 1 and set it equal to 0. And I'm going to solve each one of those. So if I come over here and subtract 5, 0 minus 5 is a negative 5. This is one of my solutions. Come over here, add 1. 0 plus 1 is 1. Divide by 2. So x equals 1/2. So the two solutions here are negative 5 and 1/2. What's another name we can use besides solutions? Roots. Okay, we can also call these roots. Is there a way I can check my answer with the calculator? Yes, we can always graph this and see if we have x-intercepts of negative 5 and 1/2. We're not going to do that because I want to make sure we get the other two done as well. All right, here we go. C. Again, same thing. First thing we need to do is get the equation equal to 0. So I'm going to go ahead and move the 8x's over to the left, so I'm going to add them. So I've got negative 4x plus 8x, which is going to give me 4x. I'm also going to take that 16, move it to the left, which now gives me a minus 16. Now I've got the equation equal to 0. Got to have it equal to 0 first. We're on step number 2, which is the factor. Anybody notice anything about this particular quadratic? There is a GCF this time. And what is that GCF? 2. So let's make sure we factor it out. We always want to factor out the GCF first. So 2 times what would give me the 2x squared? X squared. 2 times what is going to give me the 4x? 2x. And 2 times what's going to give me the negative 16? Negative 8. Now that's just the GCF. That doesn't mean we're done factoring. This thing that's in the parentheses here, we can factor that some more. As a matter of fact, those are just like the ones that we've been working on all week. I want to factor that. Just ignore the 2 for right now. We got x times x, which is going to give us the x squared. What I need to do is find factors of negative 8 that are also going to add up to a positive 2. So what are we going to do here? What 2 numbers can I use so that when I multiply them, they give me negative 8, but they also add up to a positive 2? Positive 4 and negative 2. Notice when you multiply them, you get negative 8, and when you add them, you get a positive 2. Now let's not forget about that GCF that we factored out earlier. So just throw that back in front, and don't forget it's still equal to 0. So that takes care of step number 2. Step number 3. It says here we're going to set each factor equal to 0 and solve. How many factors do I have in this one? How many factors? I have 3 factors. So I'm going to set each factor equal to 0. There's the first one. Don't need the parentheses. We're going to do x plus 4 equals to 0, and x minus 2 equal to 0. Now the first one, do I really need to worry about the first one? No. And the reason I don't need to worry about this one is because there is no variable. There is nothing to solve. So don't worry about the first one. It's the last 2 that we got to do some work on. Those are the ones that have the variables in it. So let's solve for the x. We'll subtract 4. So 0 minus 4 is a negative 4. That's one of your solutions. Come over here and add 2. Positive 2 would be our other solution. What's another name for the solution? The roots. That's a lot of work. There's a lot of places that we can mess up there. I want to double check my work here. So everybody go to your calculators real quick, and let's graph this quadratic. Let's graph 2x squared plus 4x minus 16. Let's do that real quick. Graph it, and we're going to confirm that the solutions are negative 4 and positive 2. Just double check and make sure we do have x intercepts at negative 4 and positive 2. All right? Okay, so if you're unsure about your answers, double check them with your graph. All right, that takes us through all of the practice.